You know Aurora DSQL? The team just published how it actually works under the hood, and there's this split in the architecture that sounds like it shouldn't work. Reads do no coordination at all, and they're still strongly consistent. In most databases, your read gets in line behind writes. If a client starts a transaction, grabs a lock, and then stalls, pausing for garbage collection, a network blip, someone literally walking away from their terminal, every other transaction that touches those rows backs up behind it. The paper cites multiple postmortems where the lock holder went to lunch mid-transaction, but a read isn't changing anything. It just wants to know what the data looked like at a point in time, and you can answer that question without coordinating with whoever's writing. When your transaction starts, the query processor reads its local clock. That's what decides which version of the data you get. Your read arrives at storage, says, show me this row at time 41.5, and because storage keeps every committed version, the answer's already there. Committed at t equals 41. Done. Straight from query processor to storage. All those other layers, adjudicators, journals, that's write infrastructure. Reads skip them entirely. Writes do coordinate, but the architecture compresses all of that coordination into one moment at the end. Your updates don't go to storage, the changes stay in memory until you commit. 40 statements, all buffered locally. Then at commit, one round trip. The whole batch goes to the adjudicator, gets checked for conflicts, and lands in the journal. For clients on the wrong side of a pessimistic multi-region system, each statement can mean a cross-region round trip. 40 updates, 40 round trips. Their latency climbs linearly while DSQL stays flat. About 2 milliseconds for a read, about 30 for a multi-region commit. Read-only commit is under 1.5 milliseconds. The query processor just forgets the transaction existed. Strongly consistent multi-region P99, nearly 10 times lower read latency than what the Dynamo paper reported in 2007, back when everyone assumed eventual consistency was the cost of cloud at scale. Same company, 19 years later. Clocks, networks, and the protocols all caught up, and the trade-offs stopped being necessary. The way it gets there is so cool. Massive thanks to the team for publishing this, and you can read it on arXiv.